This question is let g of x be a differentiable function. Consider the expression. The integral with respect to x of the expression, which itself is an integral with respect to x of the derivative of g of x. Evaluate this expression and simplify your answer as much as possible. Be sure to explain your steps using properties of indefinite integrals and the idea of antiderivatives. Let me walk you through it carefully. Step 1 is to focus on the inner part first. We are asked to evaluate the integral with respect to x of something that is already an integral. So, we look at the inside part first. Inside, we are integrating the derivative of g of x with respect to x. Now here's a key idea in calculus. Whenever you take the derivative of a function and then take the integral of that result, you basically get back the original function. But because it's an indefinite integral, you also have to add a constant. So, the inner integral, which is the integral of the derivative of g of x, becomes simply g of x plus some constant which we'll call c1. Step 2 is to work on the outer part. Now that we know the inner part simplifies to g of x plus c1, we plug that into the outer integral. So now the full expression becomes the integral of g of x plus c1, all with respect to x. Step 3 is to break it into two simple integrals. This is a simple situation now. We can treat it as the sum of two parts. First, we take the integral of g of x with respect to x. That gives us an antiderivative of g of x. Let's call that capital G of x. Then, we take the integral of c1, a constant, with respect to x. That becomes c1 times x. Finally, because we did an indefinite integral again, we add another constant, which we'll call c2. Final answer is capital G of x plus c1 times x plus c2. That's your complete answer. It includes an antiderivative of g of x, a linear term from the constant c1, and a final constant c2 to reflect the generality of the second integration. Let me explain in a more conversational way. This kind of problem is like peeling layers of calculus. Start with the innermost part, the derivative, and reverse it by integrating. That brings you back to the original function, but don't forget to add a constant. Then, take that result and integrate again. That adds another layer, and with it another constant. Each time you do an indefinite integral, you're opening up a family of possible functions that differ by a constant. So by the end, we have a more general expression that reflects that freedom. Whenever you see nested integrals with derivatives, just relax and start from the inside. Integration and differentiation undo each other. Just be careful to include a constant each time you integrate. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel and turn on the notification bell. Press the like button. Thank you so much.